Pero ¿cómo tienen ciertos trípodes donde dejas?
Vale.
Hace un problema.
Vale, no te preocupes.
¿Y si
Usted siempre, mi ingeniera siempre
intento...
Esta es la
Sí,
mejor.
porque si no estar ahí...
Ya, bueno, me acuerdo como los viejos tiempos.
Supongo que quiere ver todo, ¿no? Todo su panorama.
Sí, mejor allá esa mesita puede ser.
Es que no sé, ¿por qué le va a estar hablando allá?
Supongo que primero...
Pero no sé si tiene la pantalla.
Ah, claro.
Él va a estar más cerca de la pantalla, creo yo. No sé.
Supongo que sí. Bueno, ahí no se ve mal con los...
¿Qué quieres hacer ahí?
O apagado.
Yo diría que vas ahí, pero que pues
¿Acercamos?
aquí es como su cabeza.
Aquí se ve como que lo están juzgando.
Well, welcome everybody. Sorry, I wish I could say a few words in Spanish, but my Spanish is really not that good. I'm Ophelia Duroy. I will be the president of the committee for today's session, and so technologies for Amar. Your seed body weight, Maya, footsteps, sounds, Amar, the floor is yours.
Okay. Hi everyone, thank you for being here. It's really a pleasure for me to talk to you about my work, my PhD journey. And I'm going to talk about footstep sounds and body perception, and with a focus on applications for health. Let's take a look at some data. So we have 80% of people worldwide that are not so satisfied about their bodies, and even 1 in 8 of them experience suicidal thoughts due to their concerns about their body image. Negative body perceptions are entangled with many health conditions, including eating disorders and physical activity. And physical activity ranks as the 4th greatest cause of mortality worldwide. Every 52 minutes, a person dies from a direct consequence of eating disorders. But imagine that helping people and feeling our body differently, so having a different perception of our body could be easy as wearing a new shirt or putting a new pair of shoes. Imagine for a minute we get into Ana Tajadura's lab many years ago, and she puts on a pair of headphones on your ears.
Strange, I feel like my legs are almost becoming a bit tired. I feel like I'm going to be, I feel like it's rocking down the street. No, it's really noticeably different from the other condition. I really feel like I can just go trotting down the street.
Okay, so what you saw is the effects of the footstep solution, and what the person was trying was the previous version of the first device you tried today, Sony weight shoes. It was an analog device based on an equalizer, and she listened to different sound conditions: the low frequency condition amplifying the lower spectrum of footstep sounds, and the high frequency condition amplifying the high from 1 to 4 kilohertz. The effects of the footstep solution include perceived body weight changes and changes in emotional state, and also people change the way they walk, moving more dynamically or more slowly. More dynamically in the high condition and slower in the low frequency condition. These studies were also extended to the populations of interest in previous research. Used for people with low levels of physical activity and with people with eating disorders. specifically in eating disorders, to test the multisensory integration of external bodily signals in these subjects. Also, studies in gender perceptions were conducted, since the illusion has effects on whether you feel more masculine or more feminine. How does this, all of this work? From neuroscience works, we know that our body representation, how we feel our body as weak, strong, light, or heavy, is acquired through sensing and acting, and it's dynamic. It depends on the input of the signals that comes from inside our body and outside our body. There are possibilities to understand what are these mechanisms behind this phenomenon, and having this knowledge, it's possible to actually manipulate sensory signals, for example sounds or vibrations, to modify the way we perceive our bodies. This is what we call body transformation experiences. The footsteps illusion is one of them. But why are we using footsteps, and why do they have this power? I remember since I was a kid that in the beach it's very easy to follow footprints. Specifically, the ones that interest me the most were the ones with people walking kind of high heels on the beach. They are very easier to recognize. You can find some places in which there are swarms of them. They even, because I think they start conversations with other people, so you see a lot of these footsteps and footprints on the beach. And this is very interesting from the information we can know from footsteps. But the sound of footsteps is even more powerful, since imagine for a second having someone approaching behind you. The sound that comes to your ears informs you on many aspects of this person. Their posture, their gender, their emotional state, even their shoe size. And it is important to consider that heavier bodies produce sounds with lower frequencies compared to lighter bodies. What would happen if I am able to change the sounds of my own footsteps? Since sounds of heavier bursts of people are contain lower frequencies compared to lighter bodies, if I trick my brain into thinking I am producing these louder steps, these more low frequency based steps, I can trick into thinking I have a heavier body or a lighter body. Having this concept in mind and the data that we saw at the beginning, I have three main research questions in my thesis. One is to test individual differences. In particular, the population of interests are physical activity and eating disorders. In this thesis, I only want to talk only about subclinical levels, and to see whether they modulate the effects of the footsteps illusion and in which amount. And then, as a second research question, I am interested in seeing if the illusion persists over time in unsupervised settings, specifically participants' homes, but also to check whether contextual factors outdoors can influence body perception in the footsteps illusion. With the interest of checking whether physical activity can be motivated, so people can start doing more physical activity in their life and so prevent diseases. As a third research question, as you could try here, the last two devices, they are not using real-time alteration of sounds, of footstep sounds, but pre-recorded footstep sounds. So I previously recorded them and used them in a synchronized way to test again the footsteps illusion in another completely different paradigm. The objective of this thesis include to increase the theoretical understanding of sensory motor integration through the footsteps illusion, to examine individual and contextual factors and how they moderate the effects of the footsteps illusion, to investigate the persistence and longitudinal evolution of the footsteps illusion in real-world contexts, and to develop wearable systems capable of inducing the footsteps illusion. And with this, to produce all of the methodological tools needed to test the footsteps illusion in these contexts, and also the data sets that come with these studies. In this diagram, you can see how I tied the research questions with the objectives in 4 different studies. These studies include the first study in the lab to test individual differences. Then I moved to participants' homes with a more portable setup to test the long-term effects of the food substitution. Finally, I moved to research question 3, in which both of them are towards the wild, and I test synchronizing with pre-recorded footstep steps, passively and actively with a sonification technique. Let's start with study 1. The objective of this study is to test specifically the populations of eating disorders and physical activity, and the effects of the food substitution when these people try it. The main hypothesis of this study is that the effects of the food substitution would be different and more pronounced on specific populations of physical activity and eating disorders. As a secondary hypothesis, I also included body image concerns, gender perceptions, and social support networks. So let's get into it. The study included 105 participants. These were selected from 181 that selected from this pool of participants, which filled in their demographics and a long list of questionnaires that allowed me to classify them in different groups. These groups include different levels of physical activity, and so low and high, and eating disorders. So I have 4 groups. Since the biggest group I could form was 21 participants, I have 84 participants for this study, for this analysis. In study 1, I tested Sony weight shoes. It's the digital version of the device you saw in the video. So it's using 2 fundamental sound conditions and some processing for the real-time and footstep sounds that are picked up from the microphones. And since body perception changes are complex to measure, we have to include 3 different kinds of them. We have to include self-reports, and these are mostly questionnaires. We also have implicit measures, which include measures of movement and measures of physiological signals, and which reflect also changes in emotional state. To allow me to test all of these measures, I've developed a setup which consisted in a wooden runway. This is not for testing, but it's not for the measures, but to have a better representation of the footsteps in participants' headphones. So if I sound on wood, there's hollowness underneath. It sounds more than on the marble that was in this lab. So this is what I chose. I also worked with a setup that included a motion capture suit using IMU sensors and many physiological sensors on the body. These are a wired setup for the physiological sensors, while the motion captures uses Wi-Fi. To use these devices together in the experiment and to allow me to have a easier analysis and more efficient and reproducible data, I also developed a tool that allows me to synchronize the acquisition of the data from the devices. The procedure of the devices includes an acquisition of the participants' baseline measures with questionnaires and also with physiological signals, and a practice trial which included walking on the spot for 10 seconds on a runway and then walking normally on the runway for 6 times. It was 10 meters long, while I acquired physiological signals, movement, and at each turn people answered a question asking them about their body weight on a scale from 1 to 10. At the end of each trial, they also used an avatar task on a screen. People could only see the avatar, and using a keyboard, they had to match the perceived, visualized body weight they had with the avatar on a screen. I could see the value on my screen and use that data for the results. The session included, each trial concluded with questionnaires on emotional state, body feelings, and also I included body maps. We will go through them soon. The data from the study is saying that there is a replication of the effects of the main core food substitution. So people felt heavier with a low frequency condition and lighter with a high frequency condition. There are also many other aspects of body perception that were influenced by the sound effects, but we are going to focus now on individual effects, since it's the main objective of this study. We have, for eating disorders populations, we have more pronounced effects. Here I'm just showing one of the aspects of body perception. There are many that were influenced similarly. For example, on vividness of the perceived, of the experience, they have more pronounced effects, people with more eating disorders. Okay. And regarding physical activity, we have a similar effect. People with low levels of physical activity show more pronounced changes in body straightness, emotional balance, and as we can see here, other items. Not only from the questionnaire, but also from physiological signals and movement. This is important to notice and to find results like showing differences in the populations, since one, it was the objective of the study, but also to design guidelines, specific guidelines for designers when designing health interventions. So now we know that, for example, the high frequency condition has a stronger impact compared to on participants with low physical activity compared to the participants with high levels of physical activity. And this is a good result, since this population is the one that suffers the most from diseases. We have also effects on secondary hypothesis individual differences, such as body concerns, body image concerns. And here is important to notice, I just show an example, that people with negative body image feel stronger in the low frequency condition, while people with positive body image feel stronger in the high frequency condition, so in the black line. So this is informing us on another possible guideline for design, targeting specific population and specific sound conditions. This study comes also with the introduction of a new methodological tool. Usually body maps, as they are used in HCI, are mostly a qualitative tool to test devices, wearable devices, and experiments. I decided to use them quantitatively, asking participants simple questions. Where in the body you felt any changes? They marked in the body these areas, and based on the results, looking at the body maps, I understood the level at which they provided detail in marking them. And based on this, I could design the segmentation regions, which have, as you can see, different sizes from different body parts. This allows to overlap the map, the segmentation map on top of the body map, and analyze the areas that are influenced by this sound condition. I show here some examples in which I painted on the body maps the results from an analysis in which I tested some condition and the population groups. So I used the same body maps to show the areas that they failed and their changes, where they are significantly different. So for example, we can see in general we can see the high frequency condition had more effect on the higher part of the body and the low frequency condition in the lower part of the body, but then you can see at a very detailed level also changes in even fingers and different parts of the body. Then I also asked people about their social support networks. What I mean by social support networks is asking people about the people that are there for them when they need for help, or whether they need to feel relaxed, or this kind of needs. I asked them about the number of people in their networks, how they were forming different groups, so the number of groups these people were grouped. And I calculated many variables from these networks, such as the ratio of the number of people with the same sex of the participants in their network, and the difference, the age difference, so the average of the network minus the participants' age, and as you can see here, there is some examples of participants' social support networks. They use the initials of the people's names, and this allowed me to understand how these groups were composed. The results from this analysis are both from correlations and interactions. Correlations results are showing something that was expected, since we have that people with more members in their social support networks have a more positive body image. So this is their score of the questionnaire telling us about their body image. But also expected, people with more members in their network have less eating disorders. Surprisingly, we also have results on interaction with the effects of the food substitution. So we have that people with less members in their network, so with a smaller sized network, have bigger effects on perceived weight and also on other questionnaire items, while people with bigger networks have less effects. So this is telling us that there is a kind of an armor or a defense against these changes that they induce with the food substitution when people have more members in their network, bigger networks. And also this suggests that, importantly, that it is important to consider social factors in modern medicine as an intervention. Okay. And this study comes also with a data set, since all the data that was acquired from the participants were used for the analysis, but also collected in a multimodal data set. The importance of the data set is that it contains the labels and the metadata, so the answers of participants from the questionnaire, but also at the same time the data coming at the beginning of the study, so the individual differences, so scores of physical activity, eating disorders, and these are useful for researchers to predict and to work on models to predict changes in body perception. The takeaways of this study include a theoretical understanding of individual and social factors and how they shape body perception in the food substitution, and specific design implication and guidelines. I made a few examples of them while we were seeing the plots. Specifically, they belong to people with low physical activity levels and body image concerns. And this to say that it is possible to open a call for a shift toward personalized sensory technology. Technically and methodologically, I contributed with the introduction of a new device that is more portable. And I didn't say it before, but it has a really, really small latency of 1.6 milliseconds. That is close to real time. Methodological innovations include quantitative body maps and multimodal data sets. Moving to study 2, as I introduced before, this study is here to test the effects of the evolution of the food substitution in the long term. So, specifically in participants' homes, where we can test an unsupervised setup. Okay. If this would work also at home, we would have an illusion and an application that is closer to health interventions. But let's face it, the participants' setup right now was like this. So we had a prototype that was a bit bulky and a setup that was very difficult for participants to wear on their own. What I had to work on was to enhance the portability of the device, but also to decide and to choose which were the requirements for participants' homes, okay, and to design a new setup for the physiological measures and movement measures from the participants. Regarding the portability, I advanced the portability of the device with a new 3D enclosure and BCB that allowed for more replication of the device, since running a study in parallel with more participants in their homes is what I needed to make things quick. So I had to replicate the device in many units. But the most important thing regarding this advancement from sonic wave shoes to wireless microphones, sonic wave shoes, is the availability of the input and output devices. I'm talking about microphones and headphones. I had in mind the idea to move to a wireless based microphone, and since it's very difficult to wear on your own, the wired version of the microphones, while regarding the headphones, it's easier to just wear them, and the cable is not bothering so much, not impeding work. And but the headphones, actually, the ones that we used, were not available anymore in the market. So I had to find candidates that would substitute these. In an anechoic chamber, I could analyze the input-output frequency response of both systems. You can see the new in blue and the original in orange. For the control condition, for the low frequency condition, we see that for the frequency range of interest, there is no significant difference between the two systems. But in the high frequency condition, we actually see a 10 dB difference between the two systems. That left me with the questions like, would the system still induce the footstep illusion after these changes? At least we can see that the new system is going in the right direction, so it's enhancing even more the high frequency spectrum. So to test this, I conducted a study with 12 participants, and this was a 3x2 fully randomized study with 3 conditions, as study 1, and 2 systems. I tested participants with the 3 sound conditions and the old system and the new. The results are still showing a replication of the footsteps illusion on both systems. There are no significant differences between the 2 systems. So I decided to continue with this device, and now we can start study 2 again. Okay. The other decisions that were left to make were requirements from participants. First of all, I decided to focus on physical activity participants, specifically the ones that were low in the score of this question. I selected 10 participants, and they all had in their home a space big enough to walk. It was wooden or arcade. This is very easy to find in Madrid. And they were available for 4 weeks after the start of the study. The study started with a session that we did together so that participants could learn how to do everything on their own. I also included an activity using a fitness step. So not only walking, but also fitness steps, since this is being used in the past with the footsteps illusion to test whether on participants with low levels of physical activity. Not specifically the step, but also while climbing stairs. The new device looks like this, and the participants had received a pack, like a box with all the equipment necessary for their study. The other things that changed were the physiological and movement sensors setup. I decided to move to a completely wireless setup, so using these 2 devices to track everything. So I moved from ECG 3 sensor cables to a wireless ECG sensor, and on the ankle, specifically on the soleus muscle, I could measure both movement and the EMG, the muscle activity of this muscle, and is induced by walking around. The systems were selected based on the comparison with other devices, and they also were tested with 2 full study rehearsals in the lab to test their efficiency. The participants received these videos and the diary with all the instructions for the study. They conducted 2 different activities, the step activity and the walking. For each of them, they performed 2 minutes walking repeated for the 3 sound conditions in randomized order. They had to repeat these conditions for minimum 4 days a week, for 4 weeks. Each week, I also asked them to perform a 15-minute activity with the device, which included whatever the people could imagine to do with the device, the limits of safety, and not outdoors, just in their home. Yeah, these videos were provided as instructions. The procedure includes a walking task during which participants measured these signals, and at the end of each trial, they filled in the questionnaires online on bodily feelings and emotional states. They also filled on paper body maps, and always in the same order. First the walking task, then the fitness step task, and this was concluded with a daily question asking them why they chose to do the study in that moment and what was happening in their life that day. And I also had a questionnaire, an interview that was conducted weekly for 30 minutes long, usually, asking them about any doubt they could have, and also specifically seeing the body maps if there were some things that I want to clarify. The results from this study show, again, a replication of the food substitution. And interestingly, here we can see the evolution of the effects during the full duration of the study, from day 0 to day 16. We have significant results for this, for balance, emotional balance. So people felt happier in the high frequency condition, a bit less towards the end. It was also August. And less happy, let's say, in the low frequency condition. Perceived weight was influenced, as in other studies, having a coherent difference between the high frequency condition and the low frequency condition. Agency, I just put it here to it's not significant, I just put it here to show that the levels of agency are always moderately high and increasing over time. This agency is a really important factor in body illusions, since it is important to know if participants feel that the sounds they are hearing are their own or not. Those data was for the walking task. This is for the step task. We have similar results. I wanted to show the strength results, so people perceived to being stronger in the high frequency compared to the low. Usually what happens with the lab studies is that people always tell me that the low frequency condition gives sensations of weakness. But here we can see that towards the end, this condition was got closer to the high frequency condition. So we are seeing that they are getting used to and anchoring to the sound, and their body capabilities are increasing. From the participants' diaries, I've collected here some examples of body maps. We have, I've conducted a qualitative content analysis from this data that allowed me to understand the behavior and the feelings from this study. So from high frequency, people felt more motivated, more energized, and more precision in the movement. And the activity felt more playful and more engaged. Low frequency, on the contrary, showed to be people felt heavier and more fatigued and more in isolation. They also told me that the movement precision was reduced, and body control was also reduced. The activities felt longer. This is important. Considering the quantitative results and the qualitative results, we have high frequency condition as a candidate for making people feel lighter, specifically, but also more motivated. And future studies with quantitative results could also confirm these feelings of being energized or motivated with a high frequency condition. You remember I also talked about free activity of 15 minutes that they conducted weekly. This activity provided a lot of interesting feedback and design from participants. It's in the wild design that participant made. Data that shows up these activities, and these are the conditions that they choose to use. So mostly you can see that this graph is composed by green dots, so they are mostly using the high frequency condition. I also could extract more information about this. I saw that they were repeating the same activities sometimes, and this is telling us that they are anchoring and that they are deepening the understanding of the sound condition with a specific exercise in more sessions. The core takeaways of these studies include longitudinal persistence of the footsteps illusion effects. These effects reinforce and are the hypothesis is that they are reinforced by continuous sensory motor feedback that is repeated daily. In this study, I also established the basis for health interventions in physically inactive people. And methodologically and technically, I have a set of guidelines for designing this kind of studies, including wearable hardware, the choices that I made, active monitoring of data that was coming from the participants, and also this study comes with another multimodal data set with data with less participants, but with many activities in total that can be used for temporal analysis and prediction of body changes.
Go to the right. Walk past the statue. Try to walk to the sound of my footsteps so that we can stay together. And then go down the stairs, all the way to the bottom. There's a woman below talking on a cell phone.
You're not strong enough.
So as you can see here, we are moving outdoors, and we are including any other things that happen in our life. So things such as wind, other people approaching, sounds of animals in this sound. And this is just to get to study 3 that uses an outdoor setup, which I used a completely different paradigm. So now we move from real-time alteration of footstep sounds of people's own footsteps to pre-recorded footstep sounds that I recorded and made people hear, listen. In study 3, people actively synchronize with footstep soundtracks. To build these footstep soundtracks, I had to record footstep sounds from many participants using many different contextual factors, since these are the ones also that are interesting for this study. I've collected some people with different body weight, since the recordings, since the footstep sounds produce effects on body weight, it is important to provide people with sounds of their matching weight. I also recorded sounds both on the ears and on the shoes, and I asked them to work on different walking speeds, on different materials, and using different footwear. After going through the sounds, I found the ones that sounded more natural, and a piloting session was conducted in the experiment outdoor location, together with experts, to decide which sounds, which materials and footwear were the ones that had to be selected. I'm talking about the sounds, not the actual actual materials or footwear. The sounds that are corresponding to one footwear or the other. And the final decision was made on sandals on wood. Just to make you sound that they sound very differently. This is marble. Okay, and this, exactly like what we hear now, these footstep pairs, so one left and right, for example, one left and right footstep pair, loads of them were selected from the recordings, and these were concatenated in randomized order to compose generate the 5-minute walking soundtracks. these were filtered using the two different filtering processing algorithms that we saw at the beginning. High frequency and low frequency condition. And all of these sounds that are recorded are also available to be used. Just the soundtracks. In this link is just the soundtracks. Okay, so the study 3 includes two different experiments. The experiment 1 is more controlled. Experiment 2 is more exploratory. In experiment 1, I replicated a bit what happened in study 1 lab experiment. So not completely opening possibilities, but making people walk on a straight line, asking them to synchronize with the footstep soundtracks, and going through most of the same measures and procedures that we used in study 1. I measured their acceleration on the foot and self-reports from body feelings and emotional state from foot questionnaires. I also used body maps and the avatar task. I don't know if you managed to hear that there were other sounds that were coming after the walk, and this is just to show you that it is very important to understand what, to determine whether we are causing the perceptual events that we hear or that somebody else is causing these events. And this is what we refer usually as agency. In this case, imagine one of the participants who were hearing these sounds. What I asked participants is again about their perceived agency of the sounds. And the results are showing moderately high results in perceived agency and non-significant differences between the sound conditions. This is a good fact. Perceived changes of weight are also replicated from this study, showing people feeling lighter in the high frequency and heavier in the low frequency. So this is showing that the results are again consistent, even using sounds that are not at all produced by participants and not even actively synchronized, but it's people that is synchronizing with these sounds that they hear. Now we moved outdoors, but it's still just a straight line and there are no other contextual factors, the ones that I promised. Study 3 also includes another experiment, which is more exploratory and uses a full region of our campus in the university, in which participants could walk, choosing to walk on different materials under, for example, under trees or under areas covered by roofs, climbing stairs, approaching people, avoiding people, going closer to, for example, to the cafeteria. And this study was evaluated with qualitative measures. I introduced this map that I call landscape map, which includes an annotation of things that may happen while the participant was moving, a tracking path, the tracking of the path of participants' routes, and all of the rest that we see here was written during the interviews with the participants. So not only the landscape map, but also these body map stickers were placed on specific areas of the map, which where people could tell us about their changes in specific parts of their bodies, or anything else they felt. Results from this experiment showed us that people were able to synchronize, and they felt they were synchronizing mostly easily. And they also informed us about strategies they used to synchronize on the different surfaces. Obviously, imagine synchronizing to a constant soundtrack, so a constant beat, and trying to climb stairs. This is obviously more difficult. People told us about this. Agency varied specifically of these different architectural elements. And people, what they tried is to match the sound with the surface, to match the surface with the sound that they were hearing. They also told us that the presence of other people influenced their feelings emotionally and also their behavior. They also approached open or closed places according to the sound. The key takeaways of this study is a replication of the concept illusion in an outdoor environment and an understanding of the contextual factors influencing body perception. I also introduced a new setup that is just made of a headphone and loudspeaker and headphones, and a multi-purpose footstep database that can be used for other applications. Moving to the last study, I included a change in paradigm in which I wanted people to hear the sound only when they perform a step, not having to move accordingly to the sound. And this is usually defined as sonification. I used IMU sensors based on the ankles, and I used threshold-based sonification in this case. So I found the moment in which the step was starting to be performed, and I introduced a delay in the triggering of the footstep. The sounds are again filtered in these different sound conditions, and the procedure of the study that I performed while I was in IRCAM for my research stay in Paris, with 12 participants in an indoor environment. People, compared to the versions that we tried here, they didn't hear a metaphorical or synthesized background noise, but the actual background noise of the environment that was recorded previously, that was played in loop. And I measured also the same sensors that I used for the triggering are also used to measure movement data. All of this data allowed me to analyze their movement and their feelings. This is just to show how the system works. Short demo. This is the version in max MSP. Here you saw a Raspberry Pi version. This is the data coming from the gyroscope from each of the foots of the feet. So the results from this study show again a replication of the effects on perceived weight. People felt lighter in the high frequency condition and heavier in the low. They felt quicker in the low, in the high, and heavier and slower in the low frequency. And as an implicit measure, I have a significant result in step duration. People performed shorter steps in the high frequency and longer steps in the low frequency condition. This is showing again possibility to replicate the footsteps illusion using sonification paradigm. It is important to consider here some limitations, since the agency levels with these devices were lower, and I'm considering other strategies for triggering the steps, like more using multi-sensors frameworks, or using synthesis strategies, so pure sonification, continuous sonification. The potential from this device is to move to noisy environments and to such as streets, parks, anywhere you can imagine, and to allow applications such as artistic context, rehabilitation, and well-being. As an overall contribution of my thesis, I have theoretical, technical, and methodological contributions. Regarding the theoretical contributions, I have found which and how these individual traits, the ones that I tested, moderate body perception in all of the measures that I used, and also social support. I also could find a bidirectional relationship with social context, with the malleability of body perception. All of these points open a call for personalization in sensory technology. I also included some theoretical understanding of how we perceive and integrate the signals that surround us. in the full substitution. I found a longitudinal and unsupervised replication of the full substitution, and this gets closer to real-world contexts and applications for health. Beyond this paradigm, I also introduced two portable implementations that are using pre-recorded footstep sounds, not real-time alteration of footstep sounds. And this demonstrates that the footstep solution can be induced even when the sounds are not self-produced. My hypothesis is that our perception is mostly based, for this specific case, mostly based on sounds that match with our prediction and with our motor behavior. So sounds that are predictable in pace and in sound, we can integrate them. And technology, and also I delineated the effects of contextual factors in a study in which I found their effects. And technologically and methodologically, there are a set of data sets and methodological tools that come with the devices. For future work, I include the analysis of a clinical study that was already conducted with participants, with patients with obesity in the Istituto Biancavallo in Italy. So this is moving to clinical populations. And a home study data analysis that has to be conducted. The study has already been done with participants with high levels of symptomatology or eating disorders. I would also like to test in the lab singularly all of the contextual factors that I've tested in the study 3. And as you can see here, this is an example of a workshop that we conducted in the lab in which we use participatory design techniques and other qualitative methods to then analyze this data, showing how a prototype can be criticized, and for example, showing this cable is too heavy, or showing that this device is still too bulky, or like there are many ways in which things can be done better. And we have here some data, some numbers on how the amount of data that still has to be analyzed, and this is all to open collaborations to work with this data together. And now this leaves me with just a list of the academic activities in which I was involved during this time. I could meet many beautiful researchers around the world in different contexts, different international venues, and just a list of the journal articles and publications. This PhD work is part of a project contribution in which I have collaborated, and many other people in the lab also collaborated in some of the device design. Thank you so much for your interest, for your attention. And there are so many people that I would like to thank. First of all, my advisor, Ana Tajadura Jimenez, and the colleagues and the lab, my family that came from Italy, and also the computer science, mathematics, acoustics, and signal processing departments of this university. Thank you.
Thank you, Amar. Enhorabuena, congratulations to you and to your supervisor for this very interesting work, and to you for your very nice and clear presentation. it's been a pleasure to have the opportunity to try the prototypes before the presentation and to read your work. Those are, you distilled in your thesis 4 years of work in which you have brought a laboratory phenomenon out in the world through the very thoughtful and careful prototyping and engineering work, which I very much appreciate because it's directly in my own area of work, and I congratulate you for that, especially for the evolution of the prototypes and also for your commitment to leave something behind to the community in terms of the open data sets, but also the methodological tools like the body maps. So I'm representing here the computer science and the engineering department of this university, and for this reason and for my personal research interest, I will make some more maybe technical questions. And those questions are mostly driven, as I say, by a genuine interest and appreciation of your work. So, especially given your contribution also in the way that you state in your thesis document. So your goal was to enable the transition for a laboratory-bound prototypes to wearable devices using movement-triggered sonification that can be integrated into everyday life, and also contributing reusable open access data sets and novel quantitative and qualitative tools. So my first question is it's a very specific one on study 3. And correct me if I'm wrong, because I understood that you used a fixed tempo, 100 BPM, 5 minutes recorded sequence. And here it seems that to me that you inverted the original system where the sound followed the user, and here is the user who has to synchronize with the sound. So what happens with somebody whose natural cadence is very different from 100 BPS, and would that force the participant into synchronize it into something that is unnatural to them, and how much this would break the illusion?
So thank you very much for the question. And actually, to be precise, the 5-minute recording is not a 5-minute recording, but it's randomization of left and right footstep pairs that were randomized and put together. So yeah, the decisions on the walking speed was based on the fact that from research, 120 BPM is the most natural and common BPM walking speed that was usually it was used also in previous research, and that also showed to be the most natural. But in previous research, it was used mostly walking on the spot. As you can, maybe you tried also, it's easier to make faster steps on the spot while walking normally, and also for our recordings. 100 BPM sounded, felt very natural. And from the results, like posteriori, looking at the results, some participants did feel that it was a bit too slow to follow this rhythm, but other ones also mentioned the opposite. So we had to choose something what was in between, what was the fastest that was also possible to record, and since we also recorded at 80 BPM, that really sounded very slow.
And is this decision something driven by simplifying the development, or have you thought about an adaptive tempo version of it?
Yeah, another idea was to, for this study specifically for the quantitative part, it was difficult to introduce so many variables and then to have results and to analyze them. But for the future, in a systematic and a bigger study, I would include different versions of the walking speed and ask the participants to choose the ones that they feel more comfortable walking with.
So let's now move to what would you need to make your system a self-contained wearable?
But talking about, sorry, just this version of the study suite or original?
In general, just let me develop it a little bit more. No problem. Because I was really impressed by you trying to move from the first prototype into something that could be shipped to households. And I know it might seem trivial, but I know how difficult it is from having a lab prototype and then build something that has to be robust enough to enter the households and be left there for 1 month and used arbitrarily by users. And I believe that's also your vision, that like something that can be used every day in longitudinal settings and even in clinical settings. So what are the hard constraints and what would you need to do that?
I have in mind, I also put it in some of my discussion chapters in the thesis, to have a minimal device with wearable devices that people use in their everyday life, smartphones. We are getting closer to low latencies values, even on the audio components of smartphones that could allow to have in the future to have a completely portable device. So already these devices, the microphones, I'm sure you saw them used by Instagram influencers and influencers worldwide. So they're very easy to find. And they are connectable by USB directly to the phone. The phone recognizes them as a sound card, so they are already the input. Then it's in terms of computation, we will get to lower latency values for the future and have equalizations on the phone and then just ear headphones. But the idea is for me, it would be to integrate it in a mobile app. But these devices are very good to follow the legacy, to have the transition from a completely analog system to have a digital, well-engineered system, and then to move to things that are more portable.
Thank you, Amar. Let's move now to the body maps as a measurement instrument, and that's one of your methodological contributions, right? To use the body maps not as a qualitative tool, but rather as a quantitative one. And that made me trigger one. Let's say it reminded me of one eternal question that's related to the Likert scale, because in the community, there's this struggle that Likert scale questionnaires cannot be used as ordinal data. You cannot average on Likert value. But similarly, you average on the body maps drawing by users, and like if I have a lighter coloring, my lighter coloring could be different from yours. But still, you computed an average. So have you thought about this problem, or could this be an issue on your methodological contribution in this sense?
So I was thinking in a moment, I plan to provide this as a tool. I was thinking to ask specifically just a question that is quite open, to mark changes on any part of the body in which someone felt some changes. So So it's not saying use this color, use this other one, or more intensely use this marking methods or this other one. So I just considered fill, non-fill. So it's a binary decision. So it is true that this could be considered as a limitation. But since it was not asked, to provide this information in the way they fill, it was. So the data I consider is only locations on the body. But I would consider digital ways of tracking of filling body maps, and also from the participants' comments, some participants wanted to paint, for example, to tell me about their size of the body or about how deep in the body they felt these sensations. So this is opening a very important call for 3D body maps and how we could express these feelings that are not superficial but are deep or that are different in nature.
Since you mentioned the digital version, how do you think the digital version would be different from the pencil and paper?
It was already considered like at the beginning, and there is a candidate, EM Body Tool, and that it also already does this, but it allows to draw on the body like using a stylus, but and every time you work on top of that, you pass on top of it, it makes it more and more intense in color. So this is an example that is coming to my mind now, and this would be the ways to use this.
Now let's move to a more design-oriented question. Because I particularly like you mentioning the idea of creating a versatile design language. And that reminded me something in the field of end-user development that is called meta-design. I don't know if you ever heard about it. It's from Gerhard Fischer, who also stayed with us some years ago during a sabbatical, with the idea of designing not the final product, but the condition for others to design at use time. So now you have designed 4 different systems, each one used in one study. And my question is, what have you learned from building those 4 different prototypes that you would translate into a toolkit that someone, a researcher in the community or even an end user could use? What this toolkit would look like?
So this could be answered in many ways. Like if you consider design as to have devices that people could use in their life, okay, or for a point of view that the one that also driven my studies, for other researchers to use them in their studies. So in that case, I have also a set of toolkits, a set of guidelines and things that work for me for doing the studies and how these devices can be adapted. So I don't know which one. I think you are preferred more the first approach,
yeah.
The science and point of view. So yeah. So in this case, obviously, when you also tried it here, I didn't even try the first device, the completely wired one, since the sound is mostly the same, but it's more bulky. I wouldn't propose this device as a wearable device to be used in everyday life as is. So that's why this pushed me to evolve it to a more wearable setup. And in this change, this is where I understood all of the complexities. Latency increases if you move from completely wired to not wired. So I have to include devices that are affordable for latency speed. And talking about headphones, as you saw, the frequency responses, they change completely based on each of the producer and each of the models. So these are the first things I recall when I struggled like this change of devices. And then moving to another paradigm, I also, apart from what is in the thesis, I present here this version that is more portable and is more is using a version completely running in Raspberry Pi. And in this case, I saw a big evolution from MaxMSP, so from software that runs in computer, changing to JavaScript and things that were alone. And this, only using them already opened me so many other ideas that provided design content for the device that is here. So using different synthesizers for the background noise, or that already on their own they create an atmosphere or a situation in which you're walking, and then adding to this the sounds, which I think they could also be different walking sounds, not only the ones that were used for the studies. Hope I answered it.
Yeah, thank you for your answer, Amar. And now, just one last question. It's about AI. Oh no. Sorry, but yeah, no, that's because you haven't engaged with the AI during your thesis, which is good, but you, in a way, hinted to AI in so many ways in your future works and also during the presentation. One is the data sets, others could build models on. So my question is, if you had one more year of your PhD, would you yourself try to pursue some of those future direction involved AI that you've mentioned in the presentation or in the thesis, or not? And if so, how?
I consider, yeah, it's like consider 1 year wouldn't be maybe enough, but with collaborations and with other experts in the field, for sure, I would be interested in seeing the data that I on my own I collected. And I know now the feelings from a statistical point of view, or qualitatively. It would be nice to predict them or to see how these are influencing. For example, my interest would be in which of the body locations are the ones that influence more some changes, or which physiological signals is the one that is most susceptible to the food substitution. So the final answer is yes.
Are the data you collect, the data sets you created, enough to start, or you feel you should collect more data?
So for study 1, I would start from that, and I believe the results will be good, since there is a big participant pool, sample size, and also since the physiological signals to be tested are made. But moving to the other studies, I would continue with more participants. I study for the home study and also for the other studies. So I would work on new ones.
Thank you so much for your answers. That will be all for me, and congratulations again.
Great, thanks for this. And now we have questions from Julie François.
Thank you. So again, congratulations, Amar. I will repeat a lot of what Andrea said, but yeah, I think there is a remarkable quantity of work in your thesis, very, very high quality. So it was really a pleasurable read for me. I really enjoyed reading the manuscript. I think the quality of the writing is excellent. Methodologically, it's very impressive, and you have a range of contributions to different fields, from neuroscience to HCI, which is really impressive. So, congratulations for this. I also really appreciated that you both did very control studies in the lab and other studies outside, and acknowledging the challenges of running 4-week studies at home. I think that's very impressive to have done all of this in your thesis. And I think the quality of the work is evident from your list of publications, but I really want to acknowledge the effort that you've put into putting all the data sets as open data, the source code, so you've really made a tremendous effort towards reproducible, reproducible research and open science, and I think that's really nice to see. So, yeah, congratulations on this great work, and I'm happy to see that you have already started the next steps of the research. So that's really good to see. So I have a bunch of questions that are, they're ordered a bit in the order of the manuscripts. Maybe I will start with a couple of questions on the systems and the methods. So I was just curious, you said that you discarded noise cancelling platforms from the start because of the unpredictability of the frequency response. So I understand this choice for the in-lab study, but I was wondering if it would make sense for settings that are a bit more uncontrolled, because for instance, when I tried it here on surfaces that resonate a lot, like we hear a lot of the sound from the environment. So can you tell me about the scale of this unpredictability versus the scale of the frequency manipulation, and whether this choice would be really scale?
So first, before understanding, so thank you very much for the question. And before understanding the versatility and how the concept solution is actually powerful in inducing changes with a completely, like a very different hardware that we saw, it has a different frequency response. I was not aware of this fact, and so I consider the less change, the best. But so I consider it not changing, not including more unpredictability, or since noise is also unpredictable and the noise cancelling comes from an unpredictable factor, so it would also add unpredictability, and it would be difficult to show on a plot. This is what I tested, this is what participants heard, and so I chose that approach. And now that I saw also how is it possible to even with pre-recorded sounds that do not sound perfectly like the person that is walking, I would include AirPods, for example, the ones that are even that include noise cancellation, and try how they perform. The scale on which I always prioritize the frequency response of the setup in a way that is matching the original iteration of the footsteps. But the necessity of making things more portable also have to be.
Okay, thanks for your answer. I have another brief question about the last setup that you developed at Kirkham with the riots. So I was curious, could you tell me a bit more about how you came to use the gyroscopes, because we could think about just impact detection. So how did you get to your triggering strategy based on the gyroscopes? And then what variability is there between people in terms of morphology, I don't know, walking speed, like stride length, and then how does this affect the processing? Is it easy to set the delays, and did you think about maybe systems that would be a bit more adaptive to automatically tune the delay to the physiology of the person?
That's a good question. So yeah, the riots have I don't know if you work with them, but the data coming from the accelerometer is quite noisy. And for its nature, acceleration is also more impulsive and also a bit more noisy. Particularly for the riots readings, you can see. And this increases the difficulty in triggering the moment in which the footstep has to be triggered. While with the gyroscope, in combination with the location that I chose, is more naturally adapted into triggering the toe of moment, like the heel, the moment in which I lift up my heel. That is also a moment in which there is a rotation involved. So that is the standard is they chose to select. And this was better more natural since there is no impact in this phase. And the impact will be after, and it won't be on the app, it will be on the full screen impact. So it will be a direct measure. And some people in here, some of the participants also came from the IRCAM offices, were very accurate in describing how the sound didn't match, for example, with their way of working. Like having big feet, said this is, I don't hear that my sound is just so short, it's a longer footstep. So for the morphology of feet and people in general, it's still very limited for now. And I would include, for example, two sensors detection system. One would use, for example, the acceleration on the tip of the foot, and the other one could stay where it is. But at least you have two moments, and they have more information to trigger the movements.
And so, in that last study, you mentioned that people were critical about the mechanical aspect of the walking because there was limited variability in the sound because it was based on trigger. Have you thought about other ways to maybe take into account some more continuous parameters of the walk, either from sensors or from other data that would help you do forward simplification? For instance, I don't know if you know about mosaicing as a simplification technique. It's something that they developed quite a bit at IRCAM as well, where you extract audio descriptor from microphones and use this to drive the sound synthesis, so you can actually transfer the timbre, so you use some of the properties of the original sound, but then remap them on something else. Would it be an approach to that?
So I remember, Fred, you mentioned this strategy. I didn't remember the name of the strategy, but I was thinking more on a different approach of using the drives as is and using the signal coming from movement, acceleration, sensor, and use that signal as is to sonify, to synthesize sound. Obviously, the sound won't be sounding completely like a perfect sound footstep, and there will not be maybe an experience of the material that you are working on. But for sure, for the timing, it will be more accurate, and for morphology, for different sizes of feet, and different way of walking, this for sure it will be closer to participants' needs for agency.
Okay, so one last question about the methods. I mean, I have a couple of questions about the body maps, which I think is a really interesting line of work. So you said that you established the segmentation of the body maps from the data set, and I was curious about what exactly the data set influenced, because it seems fairly anatomical, especially in the leg, so I was wondering what exactly in the data helped you establish the segmentation. And then the second question related to body maps, that we see that they can be quite asymmetrical, and that sometimes this asymmetry is consistent across participants, whereas walking is very symmetrical as an activity. So I just wanted to have your thoughts about how you interpret.
So for the first questions, this procedure was actually two steps. It followed both anatomical understanding of how the body parts are and how we perceive differently in general in different body parts. And at the same time, with a data set of body maps that people drew, I was able to understand in which detail people told us about their feelings. So it was specifically seeing how many participants could told us about feelings on the thumb, or if there were. And then we saw that the people were saying only on the thumb, or only on the second finger, or the index. So they were very, very precise. This is just an example, precise coloring techniques on the fingers, for example, so that during me deciding to choose some small section, regions for that part of the body, and for other parts that we saw that they were generally not using a specific technique of coloring, but just overall telling us about the back. It's an example. So I decided to use a bigger body area in the back, or just shoulder. Shoulder. So it is a difficult procedure, I understand, since people were not there telling me anything verbally, but just drawing sensations. For the second part, that was about
asymmetry.
So asymmetry, I cannot exclude that some of the results, some of the body maps were, there were times in which participants painted the location of the prototype that was worn on one of the sites, so that that was the only asymmetrical phenomenon, the only asymmetrical thing that was on participants' bodies that could reflect also a difference in feeling something here. But also people come with different ways of working also. If you start seeing at people how they work, they all work in this weird way, and I do now because of this work. And so they really see that there are asymmetries in how they work and how they make it feel. But yeah, the microphones and the headphones are always balanced.
Thank you. So I have a few questions about proprioception across the different studies. So first of all, I didn't understand how proprioception was assessed. I don't know if it was one item in the questionnaire and then how it was formulated. I didn't find it in the manuscript. And then, so in study one, what I understood is that you observe significant differences in proprioception with decreased proprioception in the LF and HF conditions, especially with people with eating disorders. How do you interpret this decrease of proprioception?
So proprioception was always assessed as a question in the question, asking whether they could localize it more, like whether they could localize their feet while walking and hearing the other sounds. Okay, specific perception of their feet. And I don't exclude that having significant differences in proprioception is something negative, since specifically the low frequency and the high frequency are the altered sounds. It's possible that subjects feel a change in the location of these parts of the body. While in the control, at least the sound sounds the same, even if the manipulation of the sound is also physical, like we are kind of bringing the ears close to the feet because we have microphones in the feet, we have earphones here, so we are already doing something not natural for our perception, but this would be even more enhanced for an altered condition like the high and the low frequency. With participants with eating disorder, it is the relation in which there are more discrepancies between the actual body as is and the presentation that people have. So it's where I would expect also some changes in this part.
Because then I was surprised to see that in the other studies you don't replicate these results about proprioception. So it seems that in study 2, people reported having more awareness about feet localization, the ability to pay greater attention to the body and the subtleties of the environment, which points to the heightened kinesthetic awareness. And I think even in study 4, you had higher proprioception in LF and HF. So how do you interpret this difference in
So for sure, study 4, and we mentioned some other questions before, is completely another paradigm, and this is mostly so it's using pre-recorded sounds, and so we cannot say that they could really perceive their own parts of the body producing those sounds in that location. So I still need more investigation on this study for. Since agency values were low, but as you saw, proprioception were high. But for study 2, it's more like a difference between the high frequency condition and the low, that is enhancing these sensations of proprioception and localization of the foot in the high frequency condition. And I don't remember specifically now if I don't have the graph, the dots, but the precision values that the precision feeling that they have is from qualitative data that comes from the interviews and from the body maps. So also changing the tool, the measuring tool can also change it, factor it the results in this case.
Okay. Thank you. So I have, I'm curious about study 3 regarding synchronization. So before you didn't actually validate this new paradigm of footstep illusion in the synchronization paradigm before going outdoors. So I was curious to know, like, do you think there is something else happening when we're synchronizing our footsteps compared to the paradigm where we have this interaction? Did you make like even informal comparisons in the lab, and do you think that you would learn or maybe see differences if you did like a more controlled study between the two types of strategy?
Yeah, this is something that was not done, and it was study 2 was driven more like a challenge to see what would happen with amenable having a complete change in the paradigm, and tested already where the environmental factors are present, switching an explanation, like an investigation in a lab. It wouldn't require just a bigger space, since if you start synchronizing after 4 or 5 steps and the 6th, you already need to make a turn. It won't be so easy to keep this synchronization. So I think that this is the most critical need for this investigation, but it will for sure tell us if this works there, that there is something more. There is something more in our perception. As I was mentioning before, like that our body is more like perception is more based on for its footsteps, on factors and sounds that are matching in time and in other information that are possible to produce for our body, so that are predictable for our brain. So if this happens, we are able to integrate them, and we start, even sometimes we start changing our behavior with that sound. I don't know if it ever happened to you that you have a stone under a shoe or anything hanging on a shoe, and it sounds every time you perform just one of the 2 steps. After some time, when it happens to me, it changes completely the way I walk. Like I feel I'm on one side. I think this is unexplained, but one example of the analog version of what's happening.
Yeah, I mean, my question was also related. I mean, if you remember in MOCO this year, we had this keynote of Benoit Vardy and Valérie Prochain-Lecoq, who did a lot of work on rhythmic audio feedback, especially for interventions in Parkinson's disease. And they show, I mean, Parkinson's is something very specific, but they show that even for the general population, rhythmic feedback can really affect gait, and it can really affect motivation for exercise. So they work more with walking synchronized music. But I was wondering about maybe this size of these entrainment effects versus the size of the footstep illusion. And then the other aspects that I'm curious about is that it was mentioned that not everybody responds to rhythmic synchronization. Not all the population manages to synchronize rhythmically very well. And so this is why they came to do this adaptive system, resynchronized to your fundamental frequency. So I was curious, did you observe the same thing, that some people have more trouble synchronizing, and then this would be detrimental to the footsteps? And did you think about adaptive strategy?
Yeah, so first question, regarding the size of the substitution compared to just gate to rhythm, I believe that the combination is what worked a lot, since foot substitution works on a very important variable of our body perception, body weight. It's not only, oh, today I feel I can put on another jacket, or I feel like I'm cold, or it's changing completely. So some social and cultural feeling about ourselves that is very important. So it changes many other factors of our perception, and so I think that is the most strong point in favor of the substitution, and putting this factor on top of the rhythmical possibilities of continuing training with the same training with other rhythms, it makes it very powerful, I guess. So even in that presentation in Mohammad, I was very curious to see how easy it was, but then I thought, wow, we also did a demonstration at the beginning with some dance. I said the beat is very significant in our lives. It's also there in footsteps. And regarding the second question, like some participants were not good at this comes from quantitative analysis, so I knew when the footstep soundtrack started. I knew when the acquisition of the accelerometer started too, so I was able to know exactly with that soundtrack each of the peaks of each footstep and each of the ones from the acceleration, how far they were in time. So I knew like a measure, I had a measure of the synchronization performance of each of the participants. And this was not always good. And in average, it's mostly good, but at the threshold, at the threshold of becoming not so good at all. So it means that what I consider is that a lab investigation, a lab study would make participants be in a big space, would make participants be able to synchronize better. And while doing it outdoor, also with a surface that maybe is not constant, and any other distraction that could appear in the environment would affect this. So making it adaptive, but I would only do it considering what we said before, like for that approach, I would only consider a soundtrack with different pace. I wouldn't change it all the time because it depends on so many factors, and maybe it creates also some instabilities.
Thank you. I will end with two quick questions. One about, so I mean, it's great to see that you've developed these three different approaches between the transformation of your own footsteps, synchronization, and movement trigger. Do you have data about how the different strategies affect gait in participants? Or is it difficult to compare because you don't have the same setup? And then are there design implications that come from the effect of the different strategies on gait patterns? On gait patterns.
So there is the data from all the studies. It's a good news, a good answer, a good factor, since the acceleration, at least acceleration was always captured for all of the for studies, and so it is easy.
I mean, I have a couple of questions about the body maps, which I think is a really interesting that you established this segmentation of the body maps from the data set, and I was curious about what exactly the data set influenced, because it seems fairly anatomical, especially in the limbs, so I was wondering what exactly in the data helped you establish the segmentation. And then the second question related to body maps, that we see that they can be quite asymmetrical, and that sometimes this asymmetry is consistent across participants, whereas walking is very symmetric as an activity. So I just wanted to have your thoughts about how do you interpret this asymmetry.
So for the first questions, this procedure was actually in 2 steps. It followed both anatomical understanding of how the body parts are and how we perceive differently in general in different body parts, and at the same time with a data set of body maps that people could use, I was able to understand in which detail people told us about their feelings. So it was specifically to see how many participants could told us about feelings on the thumb, or if there were. And then we saw that the people were saying only on the thumb, or only on the second finger, or only on the index. So they were very, very precise. This is just an example, precise coloring techniques on the fingers, for example, so that during deciding to choose some small section regions for that part of the body. And for other parts that we saw that they were generally not using a specific technique of coloring, but just overall telling us about the back. As an example. And so I decided to use a bigger body area in the back, or just shoulder, just the other shoulder. So it is a difficult procedure again, I understand, since people were not there telling me anything verbally, but just drawing the sensations. For the second part, there's one so basically I cannot exclude that some of the results, some of the body maps were, there were times in which participants painted the location of the prototype that was worked on one of the sites, so that that was the only asymmetrical phenomenon. The only asymmetrical thing that was on participants' bodies that could reflect also a difference in feeling something here. But also people come with different ways of working. So if you start seeing people how they work, they all work this weird way, like you look because of this work. And so you really see that there are asymmetries in how they work and how they may feel. But yeah, the microphones and the headphones are always balanced.
Thank you. So I have a few questions about proprioception across the different studies. So first of all, I didn't understand how proprioception was assessed. Like I don't know if it was one item in the questionnaire and then how it was formulated. I didn't find it in the manuscript. And then, so in study 1, what I understood is that you observe significant differences in proprioception with decreased proprioception in the LF condition, especially in people with eating disorders. How do you interpret this decrease of proprioception?
So proprioception was always assessed as a question in the question, asking whether they could localize it more, whether they could localize their feet while walking and hearing the other sounds. Okay, specific perception of their feet. And I don't exclude that having significant differences in proprioception is something negative, since specifically the low frequency and the high frequency are the altered sounds. It's possible that subjects people feel a change in the location of these parts of the body. While in the control, at least the sound sounds the same, even if the manipulation of the sound is also physical, like we are kind of bringing the ears close to the feet because we have microphones in the feet, we have earphones here, so we are already doing something not natural for our perception, but this would be even more enhanced for an altered condition like the high and the low frequency. With participants with eating disorder is the population in which there are more discrepancies between the actual body as is and the presentation that people have. So it's where I would expected also some changes in this parameter.
Because then I was surprised to see that in the other studies you don't replicate these results for proprioception. So it seems that in study 2, people reported having like more awareness about feet localization, the ability to pay greater attention to the body and the subtleties of the environment, which points to maybe heightened kinesthetic awareness. And I think even in study 4, you had higher proprioception in PLF and HF. So how do you interpret this difference in
all? So for sure, study 4, and we mentioned some other questions before, is completely another paradigm, and it's mostly so it's using pre-recorded sounds, and so we cannot say that they could really perceive their own parts of the body producing those sounds in that location. So I still need more investigation on this on study 4. Since agency values were low, but as you saw, for perception were high. But for study 2, it's more like a difference between high frequency condition and the low, that is enhancing these sensations of perception and localization of the feet in the high frequency condition. And I don't remember specifically now if I don't have the graph, the plots, but the precision values that the precision feeling that they have is from qualitative data that comes from the interviews and from the body maps. So also changing the tool, the measuring tool can also change a bit, factor with the results in this case.
Okay, thank you. So I have, I'm curious about study 3 regarding
any pattern, even using AI models for some recognition of what's happening with this data. For sure, I already did the analysis and I checked whether there were like changes in speed overall, the work changing in speed in accordance with the one condition or with the other. But I didn't check its patterns that would have. And the second part
I mean, the second part was whether you would have then design implications on when to use different systems according to the effects of the
yeah, for sure. I would consider that the last version with sonic footsteps, the possibilities are mostly are many more, and allow the person to move on their own, and you can at the end of the experience you can actually see what happened with their activity. Since it's more, what I understand is that I can hypothesize that there will be more variability in a device that allows more portability, while the soundtracks, given in the form that I use, is more like follow this rhythm. So we are not asking for a variability. Maybe the variability that I can find is because of working on different surfaces. But most of the variability is when the person has some different feelings about their body or for any other reasons. They choose to walk differently, and in the last prototype they can, and even wherever they want. And maybe those would also be driven by the soundtrack, with the background noise or soundtrack that is chosen. But for sure, that is the device that I would choose.
Right, I have more questions. I will just skip to one last stupid question. Could you actually remove the digital part of the system? would you design shoes that actually shift the frequency content to higher frequencies and reproduce the effects of the footsteps illusion? Because this would be something easy to wear in daily life that would have a sustained effect as well.
Try walking.
Or I mean, more generally, like, are there studies that look at the effect of different shoe properties, weight, flexibility, on the perceived weight?
So I'm not aware of the studies using these modifications like augmented shoes or sandals that you can wear on the feet that use sound for changing how you perceive. So they mostly use vibration patterns to replicate other surfaces. So this is quite effective. So I think it would be something that for sure changes have maybe the same effect, same impact of the ones that are developed. Try walking on a crowded street if you apply what happens here in the study street, like the sunny weight companion, trying to synchronize with other people's heels or other people's shoes, it automatically feels that you are changing a bit, at least for me, that you are changing a bit how you're walking and how you feel about your body. So this is for sure something that would work on our own. But it would be more difficult to control and to design specific ones for specific populations. That was the scope of the research.
Well, thank you for the presentation and all the answers, and congratulations again.
Thanks again.
So my turn to start with congratulations both for the presentation and the work. And I was thinking it's nice actually to have the content of your PhD actually as physical objects on the table that people can try and see the trajectory. And again, I think we all were very impressed by the amount of work and knowing what it takes to collect the data, do this design, make everything open access. So that's a very impressive aspect of going on breadth and depth. So really congratulations, it's fantastic. I have organized my questions in more in the directions that I'm more an expert on, so more on the cognitive and behavioral science side. And I wanted to start with questions hearing from your perspective about some of the measures, like having deployed them across studies, how do you think of them? Will you continue with the same? And I guess the first general one is what you could see in a way is that the low frequency sounds tend to all go towards the negative in every scale, right? So people feel heavier. It's not very positive to feel heavier. They feel more tired, they feel more unhappy, and human said, that they feel weaker. And so there is eventually a worry that what you have is this general positive, negative. And then whichever question you ask, people will go in the direction of the scale, whichever polarity. So is that a concern that one should have regarding this measurements? And B, do you think there is actually an analytic strategy that would help you demonstrate that this is not the case, that this is not just driven by a general positive negativity but also
So it is something that I want to consider, looking at what we see as positive or negative. We consider, okay, this is going in the direction we want, this is going in the other. So it is a way of seeing things that can have some limitations. But there are other ways, other approaches of working with data, like qualitative approaches or approaches that embed both of the scales and both of the systems, qualitative and quantitative approaches. So I would say something that starts from the feelings that come from participants with the use of the devices. More in the wild approach, starting from there, even an evolution of the device from the feedback. So this would not ask whether this is causing this effect or not, but it's opening the possibilities for more creative and more perceptions from the device, which is something that, for example, happened for me in a workshop I organized with people in the university, which we were not pointing at a specific measure, but even if we considered the hypothesis and so on, things came during the experiment, during the experience, and people told us about what they felt openly. And this already gave me many more ideas for the future.
That's an interesting complementary thing, because people would spontaneously come up with I had a question again regarding the measurements. Having these two different sort of families of devices, in the ones which are really like following your own actions versus the ones when you're supposed to synchronize with the sounds. And you notice that actually it didn't have such a big impact on your measurement of agency, which could be surprising or not, depending on what people mean by agency. And I was thinking, you know, on the one hand, there is this idea of saying, does it feel that I caused this sound, that I am the active force behind the production of these sounds? Versus, does it feel as if, now that I have made the effort to synchronize these sounds, does it feel to me as an experience that resembles the case where I cause sounds too? And do you think that it shouldn't be important to actually try and distinguish between these two sense of agency for your future study, especially if you take the synchronization version as the one that is more likely to go out in the outer world? What people really mean by that when they said they were agency? What are your thoughts?
Yeah, since I always ask the same question, like on the perceived agency, I have some results that are, as we saw, consistent, but are not telling us more about the qualitative part, how, as if, or also ownership aspects of it, like more about the ownership, feeling that they were not only producing those steps, but they were produced by their body. So it would be good to introduce more questions to have more results on the specific areas, please. And I expect that they will find less agency in the pre-recorded versions when asking if they felt as if as they produce their sounds, since the sounds are completely related to other recordings, other people that recorded these steps. So that is what I expect, while asking the question as if it would tell me that they were able to make their sounds their own, and they integrated them, as I answered before, but the principle, the mechanism of what is happening, why we can integrate these sounds, and maybe they would score also, they will give us high scores also on this. But for sure it needs to be better investigated, the different aspects of it.
Body maps, of course, everybody mentioned body maps, so I think we all like your tool. I have to say that I never used body maps in my own experiments because they're too cumbersome to code, and I think that you have solved problems for people in the community, so thank you. But I was intrigued to know what you make of them, especially regarding design recommendations, because from what appears, okay, you have these generalities that may raise questions about should we generalize or not, and okay, somebody feels more in the small finger, in the back. I mean, what does it tell us about the experience exactly, and how do we use it in the next step? What is the relevance?
So for me first study, it's mostly related to interest in how we perceive different sounds in the different ranges of high frequency and low frequency. So there are some studies that show that high frequency sounds interest more the upper parts of our body. So this is something that was found from this study, while lower sounds are interesting more than the lower parts of the body. So this is, for example, one of the reasons why I would look at this and want to analyze more about this. But then at a specific level, I understand that maybe what I have provided now is a tool that other people could use as they want, but I didn't use this information for now.
But so I see that the sort of differences, whether it's the finger or the shoulder or, you know, what is important maybe is like higher level generalities. But I'm still wondering, is there any, do you make any like design or does it come with recommendations about the devices?
So imagine I would like to change one of these devices and make them as if, in a way that participants could wear them wherever they want. I would use body maps specifically in a study in which I asked them which part of the body they felt was more made, for example, bothering to wear the device in some area. So that would be information for where in the body to place this wearable device. But in the use I made for now is not informing me specifically for this use. So I think for now it's more like a tool, a virtual tool there, but the use can be made in the future.
And second, after measures, we'll talk about mechanisms. And you, I mean, it's clear that the illusions is grounded on things that we know very well about mechanism of multi-sensory integration, and you explained that very well. And I think it's clear that your experiments and studies were driven by this mechanistic background. My question is more whether we've learned, or what exactly have we learned that is new regarding mechanisms of sound influences on body representations or activity from your studies. The first and more general one is that although you stress in the presentation a lot of the subjective questionnaires, I think what's really impressive are really the behavioral aspect, that people change their emotions. It's something very very robust and impressive, and less prone to desirability effect. And you have also physiological effects. Shouldn't we wonder whether the sounds cause the subjective effect, the physiological and the behavioral, like this? That's the one causal scheme. Or whether the sounds cause this behavioral and physiological, and these are really what causes the subjective effects. And again, is there one of these two models the sort of parallel effects or the hierarchy? And can we think about analytical strategies to design these two models?
I think it's always, for sure, adding on top of this, it's always not only having sound that is causing effects, but it's having sound while performing the action. And the sound as its own, I don't think it would be able, for sure. But with the activity that is recording the same motor predictions and the sounds that the body would make with those movements, these effects. Behaviorally is the one that we are also more interested in movement and in emotional state. So then, I think that it would be important to have a systematic analysis of a set of specific physiological sensors and features in the movement. Then after an analysis of the current study, study 1, for example, can be proved as the most strong. the strongest. So having this set of measures, I would run a study that would make me understand more on when specifically which, not only which sound, but also which aspect of body perception, of body behavior, movements, physiological signals is influenced by a specific sound. So analytically, then it would be the idea of having a model translated from this to understand whether it's just a sound or is it.
No, because in the amount I was thinking, in the amount of data that you have, I mean, clearly structural equation modeling is something that you really useful to really, I mean, I think make a strong difference, because then you can have your design recommendation anchored on a more causal understanding of what takes precedence on what. So that's the direction of the question. On the I think it's also mechanistic side, but I think your findings show convincingly that there's something here very robust. It's replicated across versions, sets of something. At the same time, there's always one aspect, because you test them with participants. And participants are very, aware that they need to do it. It's a very high awareness. What are your thoughts regarding having something that maybe you're going to the direction, if it's embedded in your shoes, and now whenever you go and run and you wear your headphone, you can repeat the sounds. Do you think this is dependent, therefore, on attention or awareness? Or this is something that could really exist without? I'm asking you more to make an informed bet at this stage, I realize.
I'm confident it would, but I'm not sure it would be only because of the sound. I don't know if it's possible to have more footwear. If we consider more footwear producing, they are exactly the same, but they produce different sound. So we have to be sure that they are exactly the same, and they are only changing in sound, and then have this investigation and knowing what happens. But the idea is that it will also change a bit how they feel, and while you wear these different footwear, maybe it would cause also different. These changes also based on haptics or other aspects of the footwear.
The thinking is that the one where you're asked to synchronize on the existing sound, it's not, I mean, maybe people can start doing it automatically, but it's really high cognitive load, right? You need to give, otherwise at least try here. It's not something you could do with low awareness. So maybe also rating these devices in terms of how much awareness or cognitive load you have in using them. Good recommendation.
Like working, like the second experimental study 3 used a full 5 minutes duration of it. So I think that people telling us that it was easy to synchronize. I understand that after a few minutes it becomes automatic. But we don't have any measures of attention. That would be interesting.
Yeah. And I guess my last set of questions are regarding what you were saying the implications and the applications. So you mentioned personalization, and I was thinking at this stage, do you think that personalization is really driven by stable personal characteristics, like whether you're low physical activity, or your gender, age, or do you think personalization would involve knowing how you feel before putting on the device, like moment to moment?
Like tracking, like something that tracks you.
Something that knows, are you tired now? And now I will make I will set up the parameters, or I know that you're low physical activity.
There are some of the factors that for me are not changeable. Like there are things that are quite stable in our life. If we have a big social support network or not, it would be one of the things that would be more addressed, like in personalization. Like if there was a specific design for it. I would think that doesn't change from the morning to the afternoon. But there are other ones that are completely dependent on the temperature or anything else that changes, or how a person grows. Some devices, if we are designing devices for children and then they are growing, for sure there are has to be considered changes also physically but also psychologically. So for sure I would consider both approaches for the social support or for high level differences like no physical activity at all, elite athlete. We can know for sure that there is an intervention that doesn't work for one of the two and works for the other.
I'll finish with two more tricky questions, just because I have the privilege to ask the two last and I need to be memorable. So, let's say you need to pitch investor. This is a great range of techniques and technologies to help people with physical activity. And I'm an investor, and I said, yes, but people already listen to music. Depending on your soundtrack, it makes you happy, makes you run faster, and so on. So, how do you convince me that there's something that this does that music doesn't? I said it was me.
No, I think that it's for me, by my personal life, music is very powerful in doing this. So it's very difficult to answer something on the contrary. But one example is using a combination of the two. So not only like keeping the principle of the foot substitution, so a modulation with frequency of what happens with what you are hearing, but applying it to the music you're hearing. Obviously, this would say, someone would say, okay, but you're forcing me to listen to some music I don't want. But for sure, real-time design or personalized design of music can be adapted to the tastes and to the needs of the person, even in real time. But give me more intensity now, I need to run. You can feel lighter, combining the footsteps illusion with well-designed music.
I guess yes.
It won't be...
The authors of the music don't complain that you change the track. That's okay. Last one, maybe as I don't know, you will judge the difficulty later. So this was more for the physical activity side. Then I was thinking about the application for people with eating disorders and anorexia nervosa especially. So here is eventually a device that can make people change their body weight perception and feel either lighter or heavier. We know that this is already a misrepresentation, right? People with anorexia feel heavy or fat or they're not at all. Is there an ethical worry to give an illusion on top of a misrepresentation? To use an illusion to correct a misrepresentation? Shouldn't we try to use things that try to anchor people in reality rather than...
Yeah, in our daily life, most of us, some people avoid, but most of us are influenced by digital content that is always changing what we think and what we do. But this would be well designed to make things, to preserve the possible ethical considerations and also to go in the better direction, not to go in the other way. So if someone is feeling better by using it in this living a better life, I'm asking why not?
That's almost a philosophical question. So a good illusion is okay, right? An illusion that produces good effects is fine as a designer.
But for me, it's important concerning ethics, it's important not to consider that technology is the only solution, and we need something that changes the way we feel. No knowing that social support, or knowing that some of the individual differences are correlated with feeling better with body image, we can work on the psychological side or on better social networks, removing the other networks.
That's good. That was my last question. Thanks for your very sharp and honest answers. At this stage, we can have actually some questions from the audience, but only people who have actually a doctorate. So, it's selective. You can any person with a PhD who wants to ask a question. I didn't make the rules. They're not the rules. I'm sure. I mean, people have many opportunities maybe to already discuss with Amar about his research, and maybe we can then leave maybe a few words to the supervisor to close the session. And please.
Yeah, I just wanted to transmit to you that, I mean, I think that it was clear through the presentation. You all know Amar, want to know him better today. But I mean, Amar is a really hard worker. I mean, all what you saw, he did himself. He recruited participants, collected the data, analyzed the data, led the writing of the papers. He has been also responsible for the different choices in terms of study design, technical decisions. He arrived to a new lab and a new project. It was mostly empty, so we needed to take a lot of decisions on which equipment we are buying, and knowing that this is really going to influence the studies that we conduct. And he was involved in many of the decisions and in all of the ones that affected his studies, and he was very systematic and rigorous in taking his decisions and implementing also technical solutions that didn't exist, like how to connect all things together, designing an app to send the data because we couldn't send it, and he did a lot of other things that maybe are not shown, but I mean, he was also he has also been very meticulous in conducting the studies, even in very challenging situations. I mean, going outdoors, and the 1 month study at home required that he was continuously contacting the participants, ensuring that they were managing well, and looking at the data to see that everything was recorded as it should be, that participants were following the procedure. And through the years, he has been also more and more proposing new research questions and methods that have led to new results. And he has been more and more also growing into analytical reflection on the findings and the implications. And I would say that he has, I have seen that he has become an independent researcher, and that he is now able to design and conduct studies of his own. The last one, he was mostly driven all by his.
So it's not a question.
Information inside of the process.
Additional information and compliments. If I could ask everybody who is not a jury member to kindly leave the room so that we can deliberate. And, we will send someone to read that. The committee has decided to award you the title of doctor with a cum laude. So congratulations.
It usually only happens once in a lifetime. You savor the moment.
So yeah. Thank you each of you for being in this jury and for asking me all of these questions that were very, very interesting to think about. I will still be thinking about most of them. Thank you.
Thank you for the audience who have sat through the moment and shared it with Amar.
Before the parade starts, who's the sound the most?
Se me nota que hay un